How's it, guys? Welcome back to the channel. I would like to say a very big thank you to all the people who were looking forward to the debate on Saturday. I really appreciate it. And especially to Carl Edwards, Alan Evans, and Ozzy Baller, who joined me on Discord for a very nice discussion. That was very interesting and lots of fun. Thank you guys so much.
Flat and stationary and none on a planet. And there are no planets. They don't exist because there is no space. When you take out space, that takes out the planets. There's nothing there.
This is the earliest salvaged photo I found. It's from 30th of December 2019. And if you go back to my channel prior to this date, I'm sure there are still videos of Venus on there, because I first noticed Venus sometime at the beginning of October of 2019, and I did film it and I did follow it all the way to disappearing from my evening sky view and becoming the morning star sometime in June 2020. So, we define a planet as a celestial body that A, is in orbit around the sun, B, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, and C, has cleared the neighborhood around its orbit. When people want to explain the size of the sun, they say approximately 1.3 million Earths can fit inside the sun. And that's only to give us a sense of scale when we are comparing the size of the Earth to the size of the sun. But it doesn't really matter how big the sun is, because the planets are orbiting away from the sun. We are considerable distances away from the sun. And therefore, with, for example, Mercury and Venus, we actually get a window of view. The inner planets of Mercury and Venus aren't visible throughout an entire night. You can only see it very early in the morning before the sun rises, or in the evening after the sun sets, which right now I'm looking at Mercury, Mars, and Venus all setting in the west. Fight me. From this photo to the next photo is 4 months. And if you noticed where Venus was and where it is now, and fast forward 5 months later, and Venus is the evening star again. In all fairness, Venus became the evening star on the 1st of May, and I wasn't able to see it because it was behind the church. And I kept an eye on it every day until I was actually able to get this little footage on the 28th of May. So the reason it's like this is because Venus was so close to the sun at that time. When it became the evening star, it had just emerged from passing by the sun on the other side of its orbit from where we were. It's very easy to understand if you can lay it out the way the solar system actually is and forget about what you think you should see if the Earth was a globe. When we look out, we see exactly what we should see from our vantage point on the Earth, because the Earth is a globe. So we actually have a lot of information about Venus. Until about the 1960s, we didn't know much about the planet, but the Russians helped us out a lot. The Russian Venera probes to Venus were between 1961 and 1984, and on the 1st of March 1966, the Venera 3 crash-landed into Venus. Then, on the 15th of December 1970, Venera 7, as it was going to land, its parachute got destroyed and it free-falled through the atmosphere of Venus, and it lasted 29 minutes. And the Russians carried on trying, and they launched Venera 13 and Venera 14, and they made it to Venus and made it through Venus's atmosphere. Venera 13 lasted for 127 minutes and 14 lasted for 57 minutes. And that is because Venus's atmosphere is about 75 to 100 times that of Earth. Venus's distance from the Sun varies between 108 million and 109 million kilometers, and its minimum distance from Earth is about 40 million kilometers. Venus's rotational speed is 243 days, making it 6 kilometers per hour, and its axial tilt is 177 to 178 degrees to the celestial plane. And having said all of that about Venus, we know quite a bit about the moon also. And therefore, I have to ask the question again. If Venus's velocity is 35 kilometers per second and the moon's velocity is 1.02 kilometers per second, how come these two objects appear as if they are moving towards the horizon seemingly at the same speed? If you watch the video all the way through, you will see that I have 8 examples of the observations with Venus and the moon. 4 of them are in time-lapse. And when I first started noticing Venus, it was still progressing west-northwest. And on the 5th of June, that was its stop point in my sky. And then it started heading south again. How does a planet with a velocity of 35 kilometers per second simply just stops and changes its trajectory? Because we know conservation of momentum is a thing. So what deduction can we make? Why do we see these objects as we do? It's because the Earth is rotating on its own axis. And the Earth's rotation is actually slightly more than 360 degrees. That extra 0.9 degrees is the actual propulsion of the Earth in its orbit around the Sun. And that's why choose an object, any object that you can view in your skies. See it today and go and find it at the exact same time for tomorrow. And you will not find it in the same spot. All right, guys, that's it for this video. Thank you so much for watching. Please, guys, stay safe, and I will catch you in the next video. Bye.